Hello everyone. Welcome once again to another Power BI dashboard tutorial. In this part, we are learning about heart attack risk, demographics, and lifestyle factor analysis. In that data set, we have many factors. So we also have medical and clinical test factors for likelihood of heart attack in youngsters in India. So in this data set or in this part, we will see what is the effect of the demographic and lifestyle factors on heart attack risk, and you will learn how to import the data, create visuals like this, and gain some valuable insights from the data. So let's get started with part 1. Hello everyone, welcome once again to another Power BI related tutorial by Slidescope. In this part, we are learning about heart attack risk among young adults in India dataset. So this dataset focuses on factors influencing the likelihood of heart attacks in young adults, which is age between 18 to 35 in India. It encompasses demographic, lifestyle, medical and clinical data, offering a comprehensive resource for analyzing connections between these factors. Dataset is available on this particular link here under the MIT license, and we are doing it for educational purposes. So when you will download the dataset, it it will appear in a Microsoft Excel file. This is a comma separated value format data. So let's connect it with our Power BI. In Power BI, we will simply click on Get Data and use the text CSV connector here and go to Downloads or wherever you have stored your data set and just connect the CSV file. It will connect the CSV file and we will give you an overview of the data set. So here you can see we have columns like age, gender, region, whether the person belongs to urban or rural background, SES, smoking status. To me, the SES looks as socio-economic status. So smoking status, never, occasionally. So we will see the effect of smoking status on the output here, and you can see heart attack likelihood no or yes, triglyceride levels, blood oxygen level, exercise included angina, maximum heart rate achieved, chest pain type ECG result, and resting heart rate, which is BPM, blood pressure, stress level, BMI, cholesterol level, hypertension, etc. So you can see there are a lot of categorical variables, and there is sleep hours per day, screen times the person is spending hours per day, physical activity level, diet type, alcohol consumption. So we will see the effect of various input factors on the likelihood of heart attack. Now we will simply load the data here and apply changes. So by looking at the data set, we can see that the key features are as follows. Demographic features are age, gender, region, that is state or locality, urban rural residence, and socioeconomic status. Lifestyle factors are smoking and alcohol consumption, dietary preferences, physical activity levels, screen time, and sleep duration. Family history of heart disease, diabetes and hypertension history, cholesterol levels, body mass index, and stress level are medical history parameters, and clinical and test results are blood pressure, resting heart rate, electrocardiogram result, chest pain, maximum heart rate during exercise, exercise induced angina, blood oxygen levels, that is SpO2, and triglyceride levels. And our target variable, heart attack likelihood, yes or no. So whenever we are doing analysis, we always consider one variable as our output variable, and we try to see effect of various input variables on the output variable. And sometimes what in combination, what these different type of inputs, what type of effect do they have on the output. Now the potential use case can be machine learning for risk prediction, public health insights, that is identify high risk groups such as sedentary individuals with a family history of heart diseases to guide targeted interventions, lifestyle recommendation, analyze the effect of modifiable factors like diet, exercise, and sleep on heart attack risk. And there can be regional and socio-economic analysis like study disparities in heart attack risk based on geographic or socio-economic difference within India. Some insights that we can extract are feature interactions. So we can examine non-linear relationships such as how physical activity mitigates the effect of high BMI on heart attack. Clustering, we can use clustering techniques, example k-means DB scan to group individuals. So this is something that we are going to perform on Python, but here since we are doing it in Power BI, so we will start creating some insights. We'll start creating some visuals which will help us in analyzing what factors or how the different type of factors are affecting the possibility of heart attack or the risk of heart attack. So before starting our analysis, what we are going to do here, we will simply click on transform data, because in the data set we don't have any patient ID column. So in order to count how many records are there, how many patients are there, we will simply insert a index column. So we will go to add column and index column. This will start from 0. You can also index a column starting from 1. So tick here from 1, or you can align or assign a custom value also. After doing this, I will simply close and apply. So this will make the changes, and now I will have this row. Why I have done that? Because the first visual that we are going to build is a card visual. In the card visual, we are going to simply put total patients. So here we will bring total number of patients, and the index column that we have got, we will simply bring the field. By default, because it's a number, it is going to display sum, but we will do count distinct, which will show us there are 10,000 records. Okay, we will go to format visual tab and call out value, use a smaller value because we have to put many data points here, and here it is showing count of index. So in category label, we can turn off category label, and in general properties we can enable title. From here we can customize the value. We will simply put number of patients, make it bold, align it to center, and this way we have data of number of patients. Okay, for our visuals we can also give effects. In effects we can choose a color, background color, and we can choose a visual border, and for our visual borders we can choose a color and enable shadow. I will use 12 pixel as I do mostly, and here I have a simple card visual showing number of patients. If needed, we will bring more icons later, and I am going to copy this visual several times so that I can put more card data here. So here we have number of patients. Now we also have various important parameters which are related to test. For example, triglyceride level, blood oxygen level, and we also have maximum heart rate achieved. So first let us bring values like average triglyceride level in patients. So for that I will remove this, search triglyceride and bring it here. It will show us some. So we are going to use different type of aggregate values. So you can see average triglyceride level in patient is 275.01, and here we will simply write triglyceride, okay, and not percentage but average triglyceride. Obviously you can see it is reducing, so I will just write 12. I will adjust the height and width later once I see, you know, what type of values are coming and what type of title length will be needed. Similarly, what is the average blood pressure level in each patient, because blood pressure is also an important parameter for our target variable, which is, you know, likelihood of heart attack. Here you can see fast blood pressure. So seems like the blood pressure level that we are getting is not a number, that's why we are not seeing that. So let's see how the blood pressure is given. So you can see blood pressure is given as systolic and diastolic, okay. So it is given in this fraction. So what we can do, I will simply go to transform data. In transform data I will just go to the blood pressure column. I will show you why I am doing this. I will go to this column. I will split this column by a delimiter, and I am going to use a custom delimiter, that is forward slash, because the values are separated by a forward slash. And I will use each aggressiveness because only one time this delimiter is used. So 177 by 63. So I will break this column into two parts. One will be BP systolic, one will be BP diastolic. So in a normal range it is 120 by 80. So we will see a different type of systolic and diastolic values. When you will click OK, you will see that now your column is broken into two parts. So let's rename this. So I will rename this as blood pressure systolic, okay, enter, and I will rename this as blood pressure diastolic. So you can see normal value is less than 120 for systolic, and diastolic it is 80. Elevated between 120, less than 80 elevated. High blood pressure will be 130 to 139, 80, 89, and high blood pressure hypertension is stage 2, and so on. So this is data from this particular website. So obviously you can look for other websites also, but this is something that we are doing. So we have just split the column into two parts, and you can see in some cases it is 110 by 76, 108 by 73. So later what we can do, based on the BP value, we can also say it's a, you know, good good blood pressure, high blood pressure. So you can categorize also, that we will do later. Close and apply. So now we have that. So we will use two cards. So now the blood pressure, this is blood pressure systolic. So we will bring, you know, systolic, and we will bring average. Okay, this is what? This is diastolic. So we will simply call it average BP diastolic. Average BP diastolic. Later I will make sure all the spellings are correct, and here also I have to resize the title so that it fits properly. Average BP diastolic, and similarly here I am going to bring average BP systolic. And since they are given in this order, so I will just rearrange them. Average BP systolic. Okay, this is systolic. So, and obviously we have to change it. It's not 1.4 million. Average is 139. You can see in all the cases the average is on the higher side. Average diastolic and systolic BP is actually on the higher side. Average BP systolic. So we can see from the website that high blood pressure range is between 130 to 139, and around 140 is high BP hypertension stage 2. So we can see that on an average in our cases it is 139.65 and 89.73. And obviously this data is about youngsters mostly, but we will see their average age also. So we will simply bring average age here. So we have age and average. The complete purpose of this is to understand, as a beginner you will understand where to select the sum aggregate, where to select the minimum, maximum or average aggregate, so that you will, on real datasets when you will apply, you will understand where to apply this type of functions, and then when you will apply on other datasets you will have this particular example. So we have average age of 26.60 here. Okay. Later when we will bring our filters, then these card visuals will help us in analyzing further, like for different type of categorical values, what is the effect of this card, what is the effect of what is the effect on this particular data. Now another parameter to visualize will be average SpO2, which is the oxygen level. So let's bring SpO2 here, blood pressure oxygen level, and here we will bring average SpO2. We can also bring minimum and maximum, but right now we just want to see on an average. So on an average SpO2 is 94.94, which is pretty okay. Usually the normal SpO2 is around 95%, so which is okay. Obviously we are no medical experts here, we are just giving some analysis as per our knowledge. Obviously any medical expert watching this would grab much more detail than what we are getting, so we are just teaching how to use these parameters in our data dashboard report, so that the report in itself become meaningful and useful for anyone who is doing some research in this field. Also, in one of visuals as donut chart or pie chart, we are going to visualize average likelihood. So as per the case, in legend we will write heart attack likelihood and the index column that we just did. Count of unique values here will give us the heart attack likelihood data. So you can see in around 238 cases, around 20.38% cases it is yes, and in around obviously 79.62 no. We can go to formatting, I will just bring it to bottom center. Okay, increase the height a little bit so that we can see the values more clearly. And text is something I will simply would make bold, and the values that we are seeing: heart attack likelihood, yeah, it is okay, it will not be visible anyway. And here I will just write heart attack likelihood, align it to center and make it bold, remove the backward slash here. Okay, so we have this, and as we have done so far, we will also go to effect, enable a visual border, make the radius 12 pixel, enable the shadow. Usually we associate red color with a danger, so in slices we can associate yes with a danger color. For success we can use green color. Obviously to bootstrap programming we do, so you can choose whatever color you want, but here we can choose this. Okay, or we can choose primary blue color also. So obviously this is a graph that we will just keep for reference purpose, but actually we have to see the influence of different parameters on heart attack likelihood. For that we will bring a 100% stack bar chart here. Okay, obviously we are going to resize this, but what I am going to bring here in y-axis, I will bring heart attack likelihood, so this, and on x-axis we are going to count the number of values, not sum, but we are going to count distinct values. Okay, and instead of 100% stack bar, I will just change it to stack bar, so that we can see the difference also. Like yes is the number of cases in yes is less, right? For visual, instead of count of index, we will call patient count. Okay, patient count by heart attack likelihood, and here also on axis you will see that. Now in these stack bar chart we also have a legend field where we can drag a categorical variable which we can print as gender here. So you will see likelihood by patient and by heart attack likelihood and gender. So you will see here that, for example, this value, heart attack likelihood, yes, in case of female it is 946, in case of male it is 1048, and for other gender it is 44. Similarly, for no cases it is 39, 10, 38, 65, and it is 187. If you would have chosen this chart, so you would have got the percentage value. So here you can see, in case of no, the percentage of female is more than male. In case of yes, the percentage of female is is less. Okay, we will choose it like this. Now instead of applying the effect one more time, I will simply use format painter and copy the effect here. So patient count by heart attack likelihood and gender, which is good title to me, and this is something that we can keep here. Obviously we can just reduce its width a little bit so that it fits our visuals here. As we have chosen gender here, we will simply make a copy of this, and here we are going to bring the distribution between rural and urban population and see the likelihood. Here we will simply replace the gender value with population urban and rural. So here you can see in case of yes, the number of cases in rural is 872 and in urban is 1166, which kind of indicates that number of patient having likelihood of heart attack is more in case of urban population. As per this data, we are suggesting this or getting this insight. Now in the data set, when we'll go, let's see if we have region here. So you can see we have north, central, east and different regions here. So similarly, we will copy this chart, paste it here, and here we will simply use region. Okay. So region wise, you can see we have central, east and north region, and in case of no, we have this. So here we can use the 100% stack chart. We will use the vertical chart here, so we can visualize it like this. So here you can see 16%. What we can do here, let me use it like this. Can we display small numbers here? So let's turn on data labels. Position inside. Let me check. So when we will zoom it, it will be visible. So you can see in west region 60.25, where is highest? In case of yes, north region 17.32. At second number we have both east region and west region. Lowest in case of central. So this will give you region wise indication of data also. So later we can use filters to get this data, but here is the value. And obviously we are doing this. Let me rename this to HA likelihood dashboard. I can suggest you one more thing. Let's create a duplicate of HA likelihood. Summary dashboard. And in this summary dashboard, what I am suggesting is we can remove the, we can bring something like gender on x-axis and remove likelihood from here. Similarly here also, well here, remove likelihood here, and here also. I will show you why I am saying this. So obviously it will show 100%. So here we will select a cluster bar chart or a stack chart. Okay, it will be same here. So here we can use this as a filter. So when you will use this as a filter, you will see the values. Okay, for yes you can see the percentage, for no you can see the percentage. So this is something that you can also do. One more way of analyzing the same data. For example, if you will select, you will see number of patients being changed, average triglyceride, average VP systolic, average VP diastolic being changed. In case of yes, you can see there is little difference in BP systolic and BP diastolic. Average age also less difference, SpO2 less difference, but yes, these values are changing. So that is one more way of doing the same analysis. Okay, so here we are just putting everything on a same visual so that we can analyze it in a more detailed way. Now I will simply take this somewhere here, because this is our target output variable, and bring it here. And because these are our demographic values, okay, you remember when I showed you the different type of reports that we can create. So age, gender, region, socioeconomic status wise, you can put in demographic features, lifestyle factors, etc. So similarly, I am going to bring the socio-economic thing also here. Instead of urban, rural, I will bring the socio-economic status also. So you can see in case of yes, in case of middle, it is 807, low 824, and yes, uh, socio-economic status high 407. Okay. So in case of no, you can see most number is in no, that is socio-economic status middle no 3135, and we can also enable data labels here, so you will be able to see the values. Okay, and let's say I collectively want to call it demographic detail or something, so I will simply go to insert, and here I will bring shape. Okay, this shape here, and I will cover this entire thing. Okay, and in format I will send it to backward. Okay, and I will reposition these charts so that they fit this particular shape properly. Okay, and I'll just raise its height a little bit so that I can bring some text as heading here. I will bring it a little upwards so that there is a gap between these visuals, and I will simply use a text box, demographic factors. What is the spelling mistake here? I will check it later. Bold, center, font size approximately equal to 16 will not do, 14 will be okay. If we are going to choose a dark background, then choosing a light text color will be more preferable. And here we will just go to style. Okay, so text property effects, and we will disable the background. So this is going to be our demographic factors, which I have simply renamed to demographic features. So obviously we can choose a different color for background. You know, we have selected a shape also, so we can uh, change different styling or shape also. Corners are rounded good, but I will simply reduce its roundness a little bit so that it fits my requirement. Okay, so these are all demographic features. Similarly, we will also try to bring lifestyle factors like smoking and alcohol consumption, dietary preferences, physical activity level, screen time, sleep duration. So I have just shifted this graph here. Obviously I will choose a different way to display this, and here we are going to put some socio-economic factors. So let me copy this. Obviously we are going to change the styling and all. So here in a similar way we have created patient count by heart attack likelihood and smoking status. Let's visualize this. So here in case of no, likelihood is no. So you can see 4000 values, they have never done it, and in case of yes, 1000 values. Okay, and around 0.6k people who do occasionally and 0.4k people who do regularly. If you will simply bring it to percentage wise, so you will see that out of yes, if we are considering, so 19% and 30% are the numbers. So in case of who do occasionally, it is more than what it is in case of no. So from here also some meaningful insights can be you know uh, get or can be driven here. So this is percentage count of found by heart attack likelihood and smoking status. So the other factor will be alcohol consumption for lifestyle. So here we will remove legend and alcohol consumption. We can also bring something like a donut chart or a pie chart here. Now how to read this? So here you can see in case of no and alcohol consumption never, there are 47.88 cases. Okay, let's see yes. So in case of yes, never consumed alcohol percentage 12% people are there. 632 cases for yes and occasionally, and yes and regularly 198 cases, which is around 1.98% in the data. And for these type of charts where you want to display three type of values, you can also go with clustered column chart. In cluster column chart you will see more details like this. Okay, so obviously this is heart attack likelihood no, and here you can see the numbers. And wherever count of index is written, I will simply rename it to patient count. Another lifestyle factor will be physical activity in the data set. So as per the data set, if you go, you find that physical activity level is sedentary, or let's see different values here, high, moderate or sedentary. So here also we have three different values. So here also I will keep the same graph, just remove this and physical activity level as sedentary. So here we have interesting insight that heart attack likelihood, you can see this particular chart, for example, physical activity level high, in this case no is more, okay, and physical activity low, yes is low. Okay, so from here you can get that data. For sedentary and for moderate it is almost the same ratio. For sedentary also you can see in case of no, the bar length ratio is higher. So this also gives an, obviously this kind of makes sense that this is an important variable to consider for, or to consider while analyzing likelihood of heart attack. Rename it to patient count. And another factor will be screen time. So we can choose something like screen time here. And here you can see, because in screen time we have a lot of values. So for example, in case of a screen time, because it's a numerical data from 0 to 15 hours, so we have these values. So here for example, let's see a simple column chart here, and here we are going to bring screen time on y-axis, and on x-axis we are going to bring number of cases, is count of patients. Or simply swap it. So we can see that values are from 0 to 15. Okay. In legend, if we bring heart attack likelihood, then this can be another way of displaying the same data. So you can see what is the percentage of yes and no here. And we can also display it on 100% stacked. Go here in data labels, turn it on and show it inside. So it is showing like this inside, and so here you can see in case of 3 screen times are per day 3, yes value is 23%. Okay, as per the data. So this is the highest value. Somehow this is also not making too much sense here, but if you want to bring it here, you can also display it like that. In our case, we have simply displayed it like this, so you can see the number of cases in yes and no separately also. Or if you will select this, then you will be able to see it in terms of percentage. Okay, 14, 13. So this is starting from 0 and going up to 15. What are the different percentages in case of yes and no? This is not very conclusive, but yes, as per the data we have. But these are lifestyle features. And for likelihood yes and no, what I will do, because we have less space here, obviously this is count of patient. I will use likelihood as a filter. In one case I will only select yes, in one case I will only select no. And I will simply rename the title to likelihood yes and likelihood no. We can also display it in terms of percentage. So obviously, because in this case we have around 10,000 patients, so we can obviously divide it by 10,000 and get the percentage, but we are just going to show the numbers for now. So this obviously we have other factors also that we have to consider. For example, medical history, clinical and test results, and so these are two more remaining. Okay, we have created for 2 factors because there are a lot of factors, so we have created one dashboard for these 2. In a similar way, we will create another dashboard. So we will simply duplicate this and we will create similarly for medical and clinical tests. And then we will kind of combine them together. So obviously this is the first part only where we have displayed like that. This was just an example, so I will remove this from the project. So in this project, in the second part, we will also create for medical and clinical tests. This is lifestyle and demographics. And we also have some icons here that we can use in our report. So let's try this. For our header, we can create a simple text box here, and let's put the title. So title will be heart attack risk, demographics and lifestyle factors analysis in this part. Align to center. make it full width. Obviously, if we want to bring any more filters here, then we can, adjust it with like 50%, and from let's increase its size to 16, make it bold, put it in center. And we will simply style it. So this is a simple styling, and we will simply bring one image here. This is all total optional. Let's try to bring the hardware image. How it looks. For now, I will just keep this one. So this is heart attack risk, demographic, and lifestyle factor analysis. And instead of changing this, okay, I just have to copy this much. And obviously the type of factors that we are choosing here, we can also bring some icons to define that, like for example for lifestyle, or for demographic data, we can bring some more parameters that we will do in the second part. And we will simply bring one slicer here just for reference, that we can put more slicers also, or we can use this particular space for navigation also, but at this moment just let's use the slicers. And in slicers we will bring an important field here, which is the stress level, like how is the stress level related. So we will change the slicer setting to drop down, and we will simply go to slicer header and increase the font, change the color, if needed make it bold. Okay. In values we can give a very light background. As I said, very light background. Even if you want a lighter background, you can choose something like this. This just gives us a simple detail that it's a slicer. And here if we select low, for example, so in case of low you will see different values changing, stress level, medium, and in case of high you will see what is the likelihood. Obviously this data that we have got from Kaggle is obviously some random data, but if someone actually gets an actual data, right, so in that case that person will be, if you create like this, then probably you will see if the stress level are high, then the likelihood of heart attack also becomes higher. So you can see that. And before we proceed further, we will simply make a change here where we made a mistake. So this is likelihood no, and this will be likelihood yes. So we can see that it is around 20%. In case of high, percentage is around 5.8, low 5.5, medium 8.97. Okay, and this is as per the data. So that's it for the first part of this particular data set analysis. Obviously there are a lot of measures is still remaining to analyze. We will see, or we will create another graph with more meaningful insights. We will create another dashboard with more meaningful insights in the next part of this video. Please subscribe to our channel so that when we will upload that next part, you will get that insight. And we are also posting many more data analysis related tutorials on our channel, so you can find them out in the playlist itself. So see you in the next part. Thanks for watching. Have a nice day.